Okay, good day. So they will be discussing slide number 7, which is actually about data process modeling. So still we're on systems analysis phase. Okay. So the objectives, number 1 is to describe data and process modeling concepts and tools. Number 2 is to describe the symbols used in data flow diagrams and explain the rules for their use. So basically, this is what we'll be discussing for this slide. This will be about data flow diagrams. Okay. Then explain the sequence of data flow diagrams from general to specific. And then explain how to level and balance a set of data flow diagrams. And draw a complete set of data flow diagrams for an information system. Uh, but for our case, we'll be discussing more, or our main objective is for you to be able to read and understand data flow diagrams rather than drawing the data diagram for yourself. So let's proceed with the next slide. Okay, so these are the subphases of the systems analysis phase. So we have requirements modeling, which was actually, or it is actually slide number 6. And what we're doing now is more on data and process modeling. This is actually part of slide number 7. And this will be the other subphases of the systems analysis phase. So this will be discussed later in the later slides number, I think, 8 and 9. So what are data flow diagrams? Data flow diagrams show how data moves through an information system. And data flow diagrams represent a logical model that shows what a system does. So it will just show what the system does and not how it does it. So it's more on what the system will do. So it's not a very detailed description of the system. This is an example of a data flow diagram and is actually called the context diagram. Later on, we'll be going back to this. So this is just to show you how a data diagram looks like. So that's a context diagram. And on the next slide, we have here another diagram which is actually referring to the same system. It's actually the same system. So it's the same context diagram, the context diagram rather, and this diagram, the diagram 0, as you can see, it's called diagram 0, is actually referring to the same system. So we just exploded, or we just uh, we exploded this process. You notice it is numbered 0 into this diagram. So this is called diagram 0. Okay. So again, they are referring to the same system. And this is how we actually present data flow diagrams. So usually we start with diagram 0, and then we have we context diagram, and then we have diagram 0, and then we can have even lower levels of diagram. So for us to be able to understand the diagram, let us now discuss what are the elements of the data flow diagram. So the elements are, number 1, okay, let's continue. So again, we have external entities. So an external entity can be a person, organization that is outside the boundaries of the system. It can be a source or a sink. So when we say it is a source, that means that the data will be coming from that external entity. So it can be coming from a person, or it can be coming from an organization or a department. So that's an external entity. So again, if it's a source, if the data is coming from that particular entity, and it is a sink if the data or information will be given to that person or organization. So it becomes a sink. Data store is actually the repository or resting place for the data. So it is where we store data. It can be electronic, or it can also be, for example, just a piece of paper, index card, etc. As long as we store data, we write data, it is called a data store. But of course, for uh, computerized information systems, usually a data store is actually a database. The process are actually the work, task, or function that must be completed. So yan yung mga process. Then the data flow will be the parcel of information that moves between processes, data stores, and external entities. So these are the data, these are the information that moves from one process to another. So these are the elements, and I believe we can understand more of this as we go on with the explanation. And these are the symbols used for data flow diagrams. The first one, so this symbol are actually representing the process symbols. Uh, these symbols here are actually the symbols that were introduced by Gain and Sarson. So in some books, they are using these symbols. There are actually books also that are using these symbols, which was actually introduced by Jordan. So in any case, this whether the symbols used were from Gain or Sarson or Jordan, the rules will be the same except for more or less the appearance of the symbols. Okay, so let's now discuss about process. So what are processes? So process receives input data and produces output that has a different content, form, or both. So will not show how the data will be processed. It will just that's why again it will just show us what, but not the how. So it's just a black box. We don't know what is happening inside the process. All we know is this is the input, and this will be the output that will be produced by the process. So the symbol, this is from Gain and Sarson, is actually a rectangle with rounded corners. Okay. So the process name is consists of a verb followed by a singular noun. Now let's try to look at the previous let's try to look at the previous diagram. So what are the process symbols here? So we have here four process symbols. And then according to our rule, the name of the it will be the labels will be a verb followed by a singular noun. That's why, for example, here we have establish gradebook. So verb followed by a noun. Assign final grade. Grade student work. Produce grade report. So it should be a verb followed by a noun. It is obviously it should be a verb because it is a process. It has something to do with or requires some sort of an action for the input data. Okay, so that's a process. The next we have the next element, which is called the data flow. So data flow is actually a path for data to move from one part of the system to another. At least one data flow must enter and exit each process. So the symbol for a data flow is a line with a single or double arrowhead. So that's a symbol. It's an arrow or it's a line with an arrowhead. And data flow name should be consist of a singular noun and an adjective if needed. So it should be a noun and maybe followed by an adjective if only needed. So let's try to go back again at our diagram. So the arrows here are actually our data flow. Okay, so this consists of a noun, so work, and an adjective if needed. So what kind of work is this? Ito yung submitted work, and this one is the graded work. So this is a grade. So what kind of grade? Student grade. The grading detail, the final grade. So these are the data flow diagram. Again, a noun and add or adjective and a noun. So we only use adjective if necessary. So we are now on, so that's data flow. Now here we have here examples of data flow and the process symbol. As we have said last time, a process takes input and produces an output. So for the first example, the service performed will be the input for the process to create an invoice. And if you create the invoice, your output is an invoice. So we perform services, then we create the invoice, then output will be the invoice itself. We have submitted work, so maybe a work of a student. So what are we going to do with the work of the student? We grade the student work, and then we produce, in this case, two outputs. So we have one input and producing two outputs. So our output, excuse me, will be the graded work and student grade. Yes. Okay, so let's continue. Next, let's take a look at the third one. So the third one, similar to the first one, but in this case, uh, we have two inputs. That's why the arrow is towards the direction of the process. So our two inputs are hours work and pay rate. So based on these two inputs, we can now do the process, calculate gross pay. So once we calculate gross pay, our output is gross pay. So we have two inputs with one output. And here in this example, we have a sequence of processes and data flow. So the order will be our input. If we know the order, we can verify the order. So once we verify the order, the output will be accepted order. So once we accept the order, then we can assemble the order. So once you are through assembling the order, we can the output will be inventory change. So that's how we read data flow diagrams. As I've said, that will be our main purpose here. You know how to read data flow diagrams. Again, ibig sabihin, this one is input. We do the process and it produces this output. Now, here are incorrect process data flow. So we have here three examples here. Actually, the first one, this one is called spontaneous generation or a miracle. So why? Why? What do you think is called spontaneous generation or it's a miracle? So take a look at this diagram. You notice in this diagram we have two outputs, but we don't have any input. Okay. So in that case, this is a incorrect process and data flow combination. So it's impossible for a process to produce output without any input. The next one is actually called the black hole. This one. So it's the reverse of the first one. We have two inputs, but we don't have any output. So that's actually a useless process. We have inputs, but the process will not produce any output. So that's again incorrect. And the next one seems correct because we have one input and one output. But if you're going to look closely, that's why it's called a gray hole. It's a gray hole. If you're going to look at this, it looks correct. But if you're going to look at it closely, look at the process closely, we have your date of birth as our input. Then we have calculate grade, and then it produces final grade. It seems not logical. Okay, so that maybe there's something wrong with this data flow diagram. The next element is a data store. So the data store is actually called a data repository. Again, it is where we store data. That's why it's called a data repository. So it represents data that is retained for later processing. So if we place data inside the data store, we'll be using that data for later processing. There's no use of storing data if we will not be using that data later. Okay? If we place food in our ref, then that means later on we'll be consuming that food. We don't just place food there and then babayaan mo na lang yung food. Okay? The symbol for data store is actually a rectangle also with open on the right side. Again, the symbol that are being discussed or described here is actually the symbol used by Gordon, Gain and Sarson rather. So the data store name is a plural name consisting of a noun and adjectives if needed. So that's data store. Let's take a look at our previous example last time. Yeah, so this one is a data store, a rectangle with open on the right side. Okay, and then the name is actually a noun, so it's a grade book. Sometimes you can also place an adjective. So this is a data store. So again, these are process, these are data flow, and this one is an example of data store. So let's proceed. So here are correct combinations of process and data flow and data store. So let's try to read this one. That means post payment. So that means we're encoding the payment. Then the output will be the customer payment stored inside this data store. So let's say, for example, we are in a company that is collecting payments from customers. So the payments are encoded or posted, and the payments will be stored inside the data store, inside the database or something. And then maybe later on in the afternoon or at the end of the day, these stored payments will be read, and yeah, and then the daily payments will be read, and then we can prepare the deposit. So that will be another process. So yeah, we store the data, then we read the data later on. We create invoice. So when we create invoice, our output is an invoice, and the invoice that we produce as an output is stored inside the accounts receivable data store. Okay. Later on, if somebody will pay, what are we going to do? First, we read the invoice detail. That's why we have here an input, or we read from the database the invoice detail. So that's an input for this process. And then if you're going to pay, we should know what we are paying. That's why we're going to read. And then the payment will be stored inside our accounts receivable data store. So patients, let's take a look at patient. So when we admit patient, the admission form will be stored inside database or maybe parang index card or something. So for every symptom reported by the patient, we may be diagnosed, then we treat, then the treatment will be stored inside. So we have to record what treatments are given to the patient. So we store everything about the patient, the form admission, and the treatment given to the patient. Okay, so that's how we read data flow diagrams. Later on, we'll be reading the first example. So these are incorrect. So we have here a data store, then data flow going to another data store. So it means that we cannot actually move data from one store to another store without a process. Moving the data itself is already a process. So there should be a process in between data stores. For this one, the next two diagrams, actually we have a process and then stored to data store. Here we have data store. We read from the data store as an input for this process. But you notice for the data store, there should always be an input and an output. Again, we have said last time that the purpose of data store is we store data so that we can use the data for later uh, processes or for later use. We can retrieve the data for later use. But here we just store the data and then we did not use the data anymore. So here we read data from passengers without even acquiring data from the passengers. So again, for data store, there should always be an input and output.